On today's episode of Aqua Kids,
we're aging some fish.
We're what?
So, ready to make a difference?
Building a better planet starts with you. Aqua Kids, traveling around the world, going where we've never been before, having fun and so much more, learning from our friends of the sea, saving them is up to you and me. Aqua Kids.
Hey everyone at home, and welcome to a very unique episode of Aqua Kids. I'm Drew.
And I'm Katie. On today's episode of Aqua Kids, we're headed to the North Carolina Division of Marine Fisheries to age some fish.
To age fish?
Yeah. Information about the age of a fish can tell researchers a lot about the health of a population.
Sounds interesting. Let's head out to the lab to find out more.
Let's go.
We're here at the North Carolina Division of Marine Fisheries in Morehead City, North Carolina.
We're visiting a fish aging lab where scientists determine just how old fish are.
Well, let's go check in with Katie and Danielle and see how it's done.
We're here with Randy at the North Carolina Division of Marine Fisheries Aging Lab. Randy, what are we going to do today?
We're going to take an ear stone out of a weak fish.
And why would you do that?
Well, these stones are called otoliths, and they put down rings like rings on a tree.
And what does that tell you?
It tells us the age of the fish.
Huh.
So one of the reasons we need to know the age of the fish is so we can figure out the age structure of the population.
And once you have the age structure of the population, what do you do with that information?
That's what we use to figure out how many fish are out there and what regulations should be for the fishermen.
Oh, okay.
Well, Danielle, why don't you get us a fish out?
Alrighty. This one right here?
Yes.
Okay. Oh, so cold. So cold. Is this okay right here?
Mm-hmm.
Alright.
So first thing we need to do is measure the fish, and we take two different measurements. They have a little bit of a fork, but not much, and that's the little part in their tail like that.
Right.
So the first measurement we're going to take is straight down the fish. So we're going to make sure he's all the way up against the board, and the first measurement is going to be 375 millimeters. When we're dealing with fishery stuff and science, we're using metric, so 375 millimeters, and then the total length is 390 millimeters. The next thing we need to do is find out the sex of the fish. So we make a small incision with a very sharp scalpel in the belly, and we're gonna pull out
Oh, it's coming.
the gonads, which are, in this case, that is a female.
Okay. All right, so what are you doing?
So now we're going to make the cut to get the otoliths out.
Okay.
So we have the gill, and what we're going to do, this thing right here is called the preopercle. And the preopercle points to the otolith. So we're gonna put it right over top of the preopercle, and we're going to make a nice easy cut.
Whoa.
So you're not cutting the whole head off?
Not going to cut the whole head off
Okay.
because I don't want to cut the bones in half.
Okay.
So right now, you can probably finish popping that open and pull those otoliths right out.
Ooh. Do you want to pull them out?
Sure.
You see them?
This thing. Is it this thing right
You're
here?
going to be on this side.
Oh, this side? Ew, so slimy. Right here? Nope. Right here?
Nope.
Nope.
Okay, let me help just a little bit.
Okay. Oh, right
See 'em?
there. Okay. That's a toughie.
There you go.
Okay,
You can
thank
finish.
you. Okay, so these two. Woohoo.
And they're not connected. They're just two separate little stones.
Yep, they just kind of came out together a little bit, and there's the little sack that they float in that holds the bones so they can figure out which way's up.
Now, is aging something that you do every week, every year? How often do you determine the age of each population?
We do it on an annual basis, so we do it
Okay.
every year. It's important for us to know if there are any changes in the age structure of the population. So it's something that we monitor continuously.
Wow. Well, I think Clark and Drew are going to get a chance to grind those bones up and find out more about this fish.
But first, Danielle has a job to do.
All right.
So we have to put these in our data envelope. Now we can take those up to the lab.
All right.
Let's go.
What did you think of that, Katie?
Although it was absolutely disgusting, it was very interesting to learn how fish are able to use bones in order to determine what position they're in.
Don't go away. Aqua Kids will be right back. Aqua Kids presents another Aqua Kids Pop Quiz. Do you know which of these sea creatures are reported to have the longest life expectancy? Is it A, lake sturgeon, B, orange ruffy, or C, ocean quahog? Go ahead and bait your hook, and we'll be back after the break. We're back with the answer to today's Aqua Kids Pop Quiz. So, which sea creature is reported to have the longest life expectancy? If you said C, then you would be correct. It's been reported that ocean quahog can live for up to 400 years.
Welcome back to Aqua Kids.
We're going back to the lab in North Carolina to grind up those ear bones we just collected. Now we're up in the lab. The girls removed the ear bone from the weak fish, and I guess we have a sample here. So what's the next step in the process, Randy?
Well, the next thing we're going to do is we're going to get the bones out, and we are going to mark what we call the focus. And the focus is the center point. That was with the fish when it was hatched out of the egg. So that'll be the first thing that we do. And we just put a little black dot on it like that.
How do you know where the center point is?
You can see it if you look real careful. You can see where that comes in there and that comes in there, and it's going to be right there.
Cool.
So that's our starting point, and that's what we want to get down on the slide first.
Now I see these bones here. I'm guessing they're from different fish.
They are
huge.
They are. These bones are from weak fish, and the fish was not that big. But again, the weak fish have a pretty big otolith for the size of the fish that they are. But otoliths vary in size and shape with the species they come from. So that was our weak fish. And this is a close relative. It looks almost the same.
Yeah.
That's called a speckled trout or a spotted sea trout. Very close. This is from a croaker. And if you can see that guy has a strange shape to it. And these are a little more difficult to work with, but they still have the rings on them like a ring on a tree.
How about this one?
And this guy is from a black drum. He is 1,000 millimeters, so a little more than 3 foot long, and so he's as big as my leg is. Probably 60 pounds or so, and he's got what looks like a rock, but that's his otolith. And he has a really large otolith because he lives in dark, dingy water most of the time, and he's a big fish. He has big bones, so he needs a big otolith to be able to feel the vibrations differently when they hit him in the water. And yes, we can back calculate the length of the fish from the measurements that we take on the otolith. So yes, growth or length of the fish is proportional to the size of the otolith for that species.
So some ocean species of fish have smaller otoliths, and some other species have larger. Why is that?
Yeah. Okay, that's our black drum. He lives in the sound in where the water's dirty and dingy. And this is an otolith from a king mackerel, who is what is a pelagic fish. These fish weighed the same.
Wow,
and
that's
that's
so much
the size of the king mackerel, and that's the size of the black drum.
Wow.
So he's a pelagic fish. He's more visually oriented than the black drum, which uses his balance and his hearing to figure out where he's at in his environment, where the king mackerel uses his eyes.
Well, let's get grinding.
All right, well, the first thing we're going to do is we're going to get our otolith, and we already got the focus marked, so we got that. And what we're going to do is we're going to grind it on, it's called a Hillquist thin sectioning machine, and it's actually used for cutting rocks.
Okay.
But we use it to cut fish ear bones. Wow. So everybody needs some glasses.
Safety first.
That's right.
How far are you cutting the otolith?
What we're trying to do is get the little tiny thin section that's right in the middle. So we'll have the very beginning of the fish's life to the very end. So that's the part that we're trying to get the little section out of.
Show us how to do it. This is cool.
All right, like I said, this spins really fast. It's got little diamonds on it, so it goes pretty quick. But we just
Oh, wow. That is fast.
Wow.
so You can see I just got just a little tiny piece of that black mark is on there. And hopefully that'll be a good cut and we'll be able to age the fish.
And you glue it down to a slide now?
Yeah, we're gonna, we can take these off. We're gonna put some, this is a UV cured glue. It's pretty cool stuff. It actually gets hard when it gets exposed to UV light. Just a little drop of that.
So are we gonna put these in UV light and they're gonna harden up?
And they're gonna get hard in just a few minutes.
And then what do we do from there?
From there, we'll bring them back out of from under the UV light, and then we'll finish cutting the tops off and get to that final little section.
So we cut them down to a little sliver, and then
we cut them down to a little sliver. They'll be less than a millimeter in thickness, so that way we can see all the way through them.
So it's glued. So let's go cure it.
Okay, we'll go right over here and we'll put it under the light.
All right. So these should be cured in a few minutes. Oh, there it is. All right, Randy, here's the slide. It's cured.
Okay, so now we're gonna cut the top of it off and grind it back down, and we're gonna have just that thin section that we can see completely through, so we can see the rings on the otolith.
All right, let's do it.
So now we're gonna put it on the machine. Makes a cool loud noise.
Cool.
And now we're gonna grind it down.
Fine tune it a little bit. So now it'll fit under a microscope.
So now it's a little less than a millimeter thick. We'll be able to see right through it, and we'll be able to put an age on the fish.
Wow. All right, well, let's go to the microscope.
Okay.
I never knew it would take so much work to prepare an ear bone.
I know, but we can't get too tired yet. Coming up next, we finally get to age the fish.
Aqua Kids salutes Aqua Heroes, people working hard to keep the planet green and blue. Today's Aqua Heroes had many incredible journeys in the deep blue sea. Sylvia Earle is an oceanographer with an amazing career in underwater exploration, scientific and technological research, as well as in aquatic conservation and preservation. Ms. Earle is also the founder of the environmental organization Mission Blue. She has led hundreds of underwater expeditions around the world and has spent over 7,000 hours underwater while doing her research. That's close to an entire year under the sea. She has received over 100 national and international honors and was awarded the 2011 Royal Geographical Society Gold Medal. Sylvia Earle is the author of more than 190 publications discussing scientific and technical facts of our ocean's ecosystem. All her great work is definitely persuading others to make a difference.
Welcome back to Aqua Kids. We're heading to the fish aging lab to see how old our fish is.
Let's go.
Okay, guys, this is what we're gonna do. We have a microscope, and it's hooked up to a camera, and it comes out on a TV screen. So our microscope is attached to the video camera, and anyway, it goes into the computer. And anyway, now we're ready to look at the section and tell how old the fish is.
And we're using the otolith because body size is not the actual determination of the age of the fish, right?
That's right. That's why we get several samples from a different size range of fish, because a 12-inch fish might be 1, 2, or 3 years old, and we get that range, and we get the proportion of the number that end up in that range, and then we're able to take the few ages that we have and match that to all the lengths that we take from the other sampling that we do.
So Randy, we've all been waiting. How old is this fish?
Well, this fish that we did downstairs a moment ago is 2 years old. There's the first ring, and there's the second ring.
Wow.
And it's as simple as that. The focus, the area I was talking about trying to make sure that we got is right there. We got a nice sharp V. And that little area right there was with the fish when it was a small larval fish, just millimeters long. And that's the ring that it made its first year, and that's the ring it made its second year. And it put down this ring in the spring, and then the little bit of clear spot you're seeing on the other side of the second ring is the amount it's grown from in just a matter of a couple months, from the beginning of May until July.
How old do weak fish get?
Well, they can get 12 or 15 years old, but that's the extreme. That's the oldest that they live. We do have some that are right here that are a little bit older. Here's one that's 5 years old.
Wow.
There's 1, 2, 3, 4. Then the 5th ring is right there on the edge.
So we use this for the weak fish, but otolith rings can be used for a species across the board, right?
Right, and we'll do 500 or 600 weak fish. We'll do 500 or 600 Atlantic croakers. The speckled trout, we'll do 500 or 600 of those. And the real big otolith that we had, the black drum, is a species that we're just starting. So we hope to get a few hundred of those each year. But we do all different size ranges. We'll not only do the big ones, but we'll do a lot of little ones. So what we're trying to do is get ages that represent the population of the fish. Right. So the samples that we're getting are subsamples of what we're seeing out that come from the fisheries, from recreational and commercial fisheries. And what we're trying to do is match those with the ages and describe what the age structure of the stock is.
Because obviously you can't take an otolith out of every fish. So we just use this data so we can get a good idea of the size range of each fish.
Right, or the age range of the stock.
The age range
of the stock. So that's what we're trying to describe is the ages in the stock, and be able to figure out how many fish are in each size range of a certain age.
I find it so interesting that by using the ear bones of only a few hundred fish, scientists are able to determine the age range of an entire stock.
That's so true. Don't go away. When Aqua Kids returns, we talk to a fish stock assessment specialist.
Apex predators, the guardians of our ecosystem, are vanishing. The gray wolf, ancestor to our modern dog, is found scattered throughout North America, Europe, Asia, and the Middle East. Once numbering in the millions, its population has fallen below 250,000 worldwide. An intelligent pack hunter, the wolf has a complex social structure and strong family bonds similar to humans. Ancient humans learned to hunt by watching wolves. These carnivores keep herbivore species healthy by preying only on the weak and injured, preventing overpopulation and overgrazing. Habitat loss, conflicts with humans over livestock, and our fears are the greatest threats to this misunderstood creature. Find out ways you can help the gray wolf and other apex predators on our website.
Here's our top story: brown trout interfering with brook trout conservation. Over the past few years in New York State, brook trout numbers have been declining rapidly, despite efforts by many groups to conserve both their population numbers and their habitats. The statistics have been quite confusing and troubling, but a recent survey conducted by the U.S. Department of the Interior may have found an answer. The survey suggested that the introduction of brown trout stock into rivers and streams can greatly affect the native brook trout because of increased competition for food and habitat space. Unfortunately, however, both species are very important, so the question becomes, which population is more valuable? But as James McKenna, a U.S. Geological Survey scientist, commented, it might not have to be one species or another. He said, managers may be able to develop sustainable scenarios to support both fisheries. We are hopeful that a solution will be found soon. I'm Katie with Aqua News, keeping you connected to our planet. Now back to Aqua Kids.
Welcome back. We're headed down to the docks to learn more about the importance of fish aging.
All right, let's go. We're here with Laura, who is the Senior Stock Assessment Scientist at the North Carolina Division of Marine Fisheries. Laura, what exactly does your job entail?
I estimate population size and fishing mortality rates for the fish stocks that we manage here.
And how does aging play into your job?
Age data is very important. It helps us understand the age composition of the catches of the fishery and the population that's out there.
And why do you need to know this age?
We need to know the age to understand growth and for input into our assessment models.
And what is an assessment model?
An assessment model is usually a mathematical model that uses inputs like age, catch, and other information to estimate the population size of our stocks and also to estimate fishing mortality rates.
And today we looked at the weak fish. How are their populations doing in the wild?
Actually, they're considered depleted, so we're keeping a careful eye on those populations. We currently have a lot of regulations now to manage the population.
And so this aging data allows you to kind of tell scientists and other people to really keep a close eye on this population.
Exactly.
Can you tell us the value of the age data?
The age data is very important. It tells us information on the growth of the fish, how many fish are mature and contributing to future populations, and that also helps us understand how the stock is doing.
Oh. Well, thank you, Laura. We learned a lot today, and it's great to see that everyone at the North Carolina Division of Marine Fisheries is really making a difference trying to figure out these populations and how to keep them healthy. We're out of time for today's show, but I had a lot of fun learning about fish aging.
It's so cool to think that by just using an ear bone, it's possible to determine how old a fish is.
Not only that, but by using age information, scientists are able to determine population sizes of entire stocks.
And this then allows them to set stricter fishing regulations when populations are low. How cool.
That's right, Drew. It's great to see that everyone at the North Carolina Division of Marine Fisheries are working hard to make sure fish populations are healthy. They help us to remember that everyone can do their part to keep our planet green and blue.
And so can you.
So visit our website to follow us on our journey.
And learn how you can come along with us.
And together we can help keep the world
and the water
a great place to play and explore.
And we'll see you next time
on Aqua Kids.
Aqua Kids.